For part two, let's talk about object components, or really what we're talking about is the has-a relationship. So in C++, we do the has-a by making something be a member of your class. So for example, we have the class engine, and we say we have a car, class car has a engine. Now, structurally, you could say a car is a engine. You could do that. You could say car is a engine, and that has other members added to it. But it's first of all, it's sort of nonsense. But it can be more practical to use this has a relationship. And let's take a look at that as a game object. So let's say a game object has a transform, and a game object maybe it has a mesh on it. Maybe it has a rigid body be part of the physics system. Maybe it has an animation controller on it. So by layering these things in a has-a, we're going to be able to avoid the inheritance diamonds and the bubble ups that we ran into before. Here's how that might look in C++. Apparently I dropped the transform because, make it fit on the page. But we have their mesh instance, which is, a pointer, animation controller pointer, rigid body pointer. And so by having these pointers, I can make them null if I want. So I can say an object may or may not have a mesh on it. An object may or may not have an animation controller. And that can be pretty useful so that we can, avoid that bubble up problem and the diamond problem by just mixing and matching things as needed. Okay, so then we might still use inheritance on top of that, and I've made a very, very simple class here, which all it did was override the constructor to fill in that pointer with a concrete element. That's something you could do. So we still have a bit of inheritance going on here, but the idea is that we make the inheritance a lot more shallow. We don't go as deep with it. For example, we might say that all of these components that we're making part of the game object, let's have them all inherit from a base class called component. That's going to allow us to, instead of listing them individually, instead of having the mesh instance pointer and the rigid body pointer and the animation controller pointer, we can now just have a list of pointers. And since they all share that same base class, this list of pointers can hold any kind of pointer. And that will allow us to extend. The real power of that is that we can extend what a component means. And then each game can have their own components. Like, Pac-Man can have a power pellet can have a component on it that wouldn't make any sense in GTA, right? And GTA is going to have, cars with vehicle components on that. Doesn't make any sense in Pac-Man, right? So by doing this, we are making a game engine that is flexible enough that people can just add stuff to it. Just by inheriting from component, you can throw that onto an object. So let's take a look now at some of the advantages and disadvantages of the component model versus the inheritance model. First here, the component model does not require you to have any subcomponents that you do not need. Right? That's the pure one, the list that we just showed. So if you don't need to have a transform on this object, you don't have to put a transform on the object. You don't need a rigid body on it, you don't put a rigid body on it, right? If this crate cannot float, then don't put the floating component on there. Okay, that's what that is. Number two, makes it very easy to mix and match. What do I mean? A classic example I like to give is the penguin, right? In your basic hierarchy, you say there's different kinds of animals. We have class animal, and we have fish. A fish is an animal. A fish is an animal that swims. And then we have a bird. A bird is an animal that flies. And then some joker goes and they make a penguin, which is a bird that swims. And you're going, we're back to Diamond Land, right? So to avoid that, instead, we say that an animal has components. And one of those components is feathers, right? So we have an animal with feathers, and we'll stick the swimming component on there. And boom, now we've got a penguin. We are able to mix and match different things. You can make a platypus, right? By putting different components in there. Okay, disadvantages. Let's talk about disadvantages of the component model. Okay, I just showed those pointers, right? If we're going to allow those things to be pointers, that means they're going to point to different places in memory, and we learned how that's going to jumble up our memory usage, and it could thrash the cache, right? And that was really why I mentioned in Command & Conquer 3 we did not use this, and that's why, because we wanted it to be, very straightforward in the memory. Okay. Lots of all those pointers. Don't forget, every time those pointers are there, that means there's a new and there's a delete, and those are really easy to get mixed up. How often do we forget to delete, or we reference a pointer that's after it's been deleted? So there's trouble there. That's a little difficulty. And then here's one that gets quite tricky, actually, and that is that sometimes the different components need to communicate in some way. Let's say there's a hit point component, a damage component, and then there's the destructible crate component. So when the hit points of the crate hit 0, we need that crate behavior to trigger. So somehow we need some kind of communication, right? Okay, and so one of the approaches we'll use is messaging, which is that we won't have them know about each other directly. Instead, the hit point component will just broadcast a message that says, I've been destroyed. So I'll send the I've been destroyed message to the entire object, and any components on there that are interested in that message will react to it. But you can imagine that can be pretty inefficient to do all of that messaging around when you could have just said, call the function explode or something like that.